In the last video, we built a tiny Outer Wilds style star system in Godot. In this episode, we're going to clean it up a little. We'll bake our prototype CSG planets into real 3D meshes and collision shapes. We'll build a better orbit workflow directly inside the Godot editor, and we'll improve how the timing works in the simulation. By the end, we'll be able to reshape the entire star system in real time without even pressing play. Last time, we built the foundation for our little toy star system. You can go back to watch that video, but here are the highlights. We created orbiting planets and moons using constructive solid geometry, or CSG for short. We used some procedural shaders to give the planets some paint. We added real-time orbit calculations and visualizations. And we started with a 6 degrees of freedom player controller using a character body 3D physics node. And honestly, for a first pass and being completely new to 3D and Godot, it worked pretty well. While working on the next phase of the project, I started noticing a few pain points. The planets were still based on temporary CSG geometry. The orbit editor workflow was getting messy, and once the orbit tool script started running in real time, it became difficult to actually work inside the scene without the whole star system constantly moving around. So before we jump any further into the player physics, I wanted to stabilize the celestial body system a little more. First, let's address the CSG shapes we used to rapidly prototype the planets. CSG is incredibly useful when you just want to throw shapes together and quickly test out ideas. It's great for experimentation. But eventually, those temporary construction shapes start to get more complex and become CPU intensive. They're slower than regular meshes, they're awkward to organize long term, and they're really meant more for prototyping than for finished game assets. So I wanted to try baking the CSG planets into real 3D geometry. Fortunately, Godot makes this pretty easy. All I needed to do was select the CSG Combiner 3D node for a planet or a moon, and use this CSG button here to convert the combined CSG into both a mesh and a collision shape. It generates a real 3D mesh asset directly from our procedural CSG shape, and places the mesh next to the original CSG shape in the scene tree. I also did this for the 3D collision shape, and now we have both the visual and the collision shapes. And I finished up by swapping out the old CSG node, and using the baked geometry like a normal model. Simple. This gives us a much cleaner foundation moving forward, and is much more efficient during runtime, especially once we start adding more complicated terrain features and structures onto the planets later in the series. And importantly, the planets now feel less like temporary editor experiments and more like actual 3D nodes. Later, we can improve this workflow further, even try importing meshes from other applications. But for now, this will let us turn the CSG shapes into meshes and colliders, and even repeat the process again when we want to make changes to the original shapes. Great! Now that the planets are more performant to work with, I wanted a better way to actually adjust the star system itself. And this is where the orbital elements are used. Last time, we used Keplerian orbit elements to place the planets into motion, but we kind of glossed over what those values are actually doing. So let's slow down for a second and look at the 6 orbital elements that define an orbit in 3D space. I like to mentally split these into 3 groups: the values that define the shape of the orbit, the values that define the orientation of the orbit, and a timing value that determines where the body is currently at within the orbit cycle. First, the shape of the orbit. The semi-major axis element controls the overall size of the orbit, while the eccentricity element controls how stretched out the ellipse becomes. So with just these 2 values, we can already create circular or highly elliptical paths. Next comes the orientation of the orbit in 3D space. This is where it gets more complicated than our simple 2D gravity simulations in earlier videos. The inclination tilts the orbit plane. The longitude of the ascending node rotates where that tilted orbit crosses the reference plane at the equator. And the argument of periapsis rotates the ellipse inside that orbit plane. Together, these 3 values fully orient the orbit anywhere in 3D space. And finally, we have the timing component. The mean anomaly at epoch determines where the planet starts along its orbit at the beginning of time, This is where the body will start when we first run the simulation. I also added some new rotation settings for the planets. So now we can change their axial tilt and better control the speed and direction of their rotations. Now, because all of these are exported variables in Godot, and because we're using tool scripts, we can tweak these orbits live in the editor and immediately see the planets and orbit lines update in real time. That means we can literally sculpt the orbits interactively without ever pressing play. It quickly became one of my favorite parts of the entire project so far. Of course, since the planets were moving directly inside the editor, I ran into a problem pretty quickly. Sometimes you just want the planets and moons to stop moving. Trying to position the cameras, debug objects, lighting, and gameplay elements while the planets are drifting around gets annoying pretty fast. So I added a proper editor time control for the planets. It starts by separating the idea of simulation time during runtime and the editor preview time. By default, this new Animate in Editor setting is disabled, and so the planets freeze at their official starting positions while inside the editor. When enabled, though, this extra editor time variable will be automatically incremented, and that'll cause the bodies to move while they're in the editor. This way I can inspect the orbit layouts, tweak their parameters, and set up the scene without fighting moving targets. This ended up becoming one of those tiny quality of life features that sounds pretty boring, but immediately became useful once I started adding more and more features to the project. And now I can slow the system down for debugging, speed it up to see how it's going to look in the future, or completely freeze the planets while editing terrain. That small improvement made the entire project feel dramatically more manageable. At this point, the star system felt dramatically more stable than it did in the first video. The planets are cleaner and will be more efficient, the orbit workflow is interactive, and the editor controls are far more usable. And we finally have a proper simulation timer for the orbit physics. There's still a lot ahead of us. We'll eventually improve the orbit systems further, experimenting with more interesting orbit types like retrograde orbits, and start adding real structures, caves, and terrain onto the planets themselves. But in the next video in the series, we're going to focus entirely on player movement, gravity, and the camera controls. And surprisingly, we're probably going to move away from character body 3D entirely, and switch over to our RigidBody-based controller instead, which opens up a whole new set of challenges. So if that sounds interesting, don't forget to subscribe and turn on notifications so you don't miss that next episode. Thanks for watching the Pathfinder's Codex, and never stop trying new things.